Okay, so let's continue. Just real quick, this was negative 5/7. It's negative 5 over positive 7. So it's not up here, it's actually down here. Just a quick correction. So this is positive, so all numbers between negative 5 and negative 1 are positive. This was negative, so all the numbers should be negative. And lastly, we got to plug in f of 2. So I'll put it down here. So we have negative 6, negative 5/7. F of 2 is 2 plus 1 over 2 plus 5 times 2 minus 1. That's 3 over 7. So that's positive. 2 3/7. Plot 2 3/7. It's about 1/2. So let's talk about what this means. If all the numbers to the left of negative 5 are negative, that means is it going up or down towards this asymptote? It has to be going down because all the numbers are negative. As it's going left, it can't cross the axis because of the horizontal asymptote, but more importantly, there's no zeros there. So it means as it goes to the left and goes towards that 0, the horizontal asymptote, it kind of just levels off, gets close to the 0, but never touches. In the middle, between negative 5 and negative 1, it's positive numbers, which means from the asymptote, it's going to be going up top, eventually curving down and going towards the 0. Because from negative 1 to 1, the numbers are negative, so the same argument here means it must be going down because all the numbers are negative. And lastly, on the right side, it's positive, so it must be going up towards the asymptote, and again, it must be leveling off, but here it must be leveling off above the axis because all of those numbers are positive. So the pink line you see is the actual graph. The black lines, which were the asymptotes, are there to guide you to this point. Now the ones with multiple vertical asymptotes are complicated looking like this. It's kind of a strange looking picture, but it's kind of interesting as well. So let's look at another one here. Do this all again. X cubed minus 4x squared plus x minus 4. So we fully factor everything. The numerator actually factors by grouping. The first two share an x squared, the second two share a 1. So that would be x squared plus 1 times x minus 4. In the denominator, it's x minus 2 and x minus 4. Which means we have something that will cancel. So it's x squared plus 1 over x minus 2. And we need to make a note of a whole. It's at x equals 4. But I have to plug 4 in to see the y value. So 4 squared plus 1 over 4 minus 2 is 17 over 2. So it's at the point 4 17/2. So how we graph a whole, and we'll do this right now. So we make an open circle at that point, so over 4, up to 17 over 2, which is 8.5. We just make an open circle here. But we can still use that point later on when we're doing our test chart. So what's remaining in our denominator here? We have a vertical asymptote. It's x minus 2 equals 0, so x equals 2. So we go to find 2, and we make a vertical dotted line down here. I know it's hard to see, but this is x equals 2. And here it's going up and down all the way. Okay, what's left? Horizontal or slant? Where's our function bigger? Numerator or denominator? It's the numerator is bigger than the denominator by 1, which means we have a slant asymptote. And I've got to use division. So 2 on the outside when I'm dividing by. It's 1, 0, 1 on the inside. So 1 comes down. 1 times 2 is 2. 0 plus 2 is 2. And again, we don't care about the rest. This is the line y equals x plus 2. Again, this is an asymptote, but instead of taking a vertical line, this is going to take on the shape of this line y equals x plus 2. So a dotted line It starts at 2, a rise over run of 1 over 1. So I'm starting at 2 here, and I'm going to make my first dash here through it at the slope, up 1 over 1, up 1 over 1, so on and so forth, to match the slope, and down on the other side. So instead of on the outside, it turning towards a horizontal asymptote, this is the line that's going to guide it on the outside of the function. I still need to do the intercepts. The x-intercept is when the numerator is equal to 0. So when is x squared plus 1 equal to 0? Never, because when is x squared equal to -1? Well, when x is either I or negative I, but those aren't going to appear on the graph, so there are no x-intercepts, which means this should not be crossing 0 at all anywhere on your graph. What about the y-intercept? All I have to do is plug in 0 to what remains. Well, it's x squared plus 1 over x minus 2. 0 squared plus 1 over 0 minus 2, which is just -1/2. That means we have the point 0, -1/2 on the graph. I will go ahead and plot that. 0, -1/2. It is a filled-in circle, unlike our hole. It's actually on the graph. Okay, so when we make our test chart, the only place where we can jump from positive to negative, because we have no x-intercepts, is at our vertical asymptote, so where x is 2. An easy number less than 2 would be 0. An easy number bigger than 2 is 4. Why did I pick 4? Because we already plugged it in for the hole. We know that when we plugged in 0, we got a negative number, because it was 0, -1/2. We plugged in 4, we have a positive number, because it's 4, 17/2. That means all my numbers to the right of 2 are positive, and all the numbers to the left of 2 are negative, which means I can use my asymptotes to my advantage in this kind of situation. So on the right side, it curves presumably down. We don't know exactly where, but it's a sketch. So roughly, we know it can't go above the 0. On the left side, it's got to curve towards our slant asymptote. Doesn't touch it, but it curves towards it. By the way, let me put this is the line y equals x plus 2. On the right side, everything's positive. So we know from here, it's going to go up. It's got to jump over the hole, but it's still, the rest of the behavior is the same. It curves towards the asymptote. And so this is what this graph looks like, which is a little more simplified than the double vertical asymptote situation, but there's still a lot of stuff going on there. With the slant asymptote, the end behavior, they're still going to go down to -infinity or up to +infinity eventually, but they have a path to get them there. We have our hole from the equation, and really that's all there is. The pink parts, again, the graph, the black asymptotes are not part of the graph. So again, on your homework, all you would see if you had a multiple choice question is the pink part of the graph. You kind of have to assume that area that things are curving towards are the asymptotes you're dealing with on the homework. And really, this is all for 3.5.